Every process has flow, and at some point, every process engineer has to answer the same question. Which flow meter is right for this application? Get it wrong, and you're dealing with inaccurate readings, maintenance headaches, and equipment that doesn't survive your process. Get it right, and you have reliable data, a lower total cost of ownership, and one less thing to worry about. In this video, we're going to walk through how to actually make that decision, step by step.
This video is brought to you by George Grant Company, a specialty industrial manufacturer's representative serving chemical, pharmaceutical, oil and gas, food and beverage, pulp and paper, and heavy industrial facilities across the Southeast. Let's get into it. Flow measurement sounds simple. Fluid moves through a pipe, you measure how fast or how much. But the reality is that no single flow meter technology works for every application. The variables that define your application, your fluid, your pipe size, your process conditions, your installation constraints, determine which technology is even viable, let alone optimal. So before you spec anything, you need to answer 6 core questions. 1. What is the fluid? Is it a liquid, a gas, or a slurry? Is it clean, or does it carry solids? Is it conductive? 2. What is the line size? Flow meter selection changes significantly from a 2-inch line to a 36-inch line. 3. What is the flow range? You need a meter that performs accurately across your minimum and maximum expected flow rates. 4. What accuracy is required? Some applications need 0.5%. Others can work fine at 3%. That changes your options significantly. 5. Can the line be shut down for installation? If not, that eliminates most intrusive technologies right away. And 6. Is the area classified as hazardous? That adds requirements around certifications and approvals that not every meter meets.
The first technology we'll cover is differential pressure measurement, specifically V-cone technology.
The V-cone meter places a cone-shaped element in the center of the pipe. As flow passes around the cone, it creates a pressure differential that correlates directly to flow rate. This technology is exceptionally well-suited for applications where straight pipe run is limited, a common problem in retrofit and brownfield installations. It handles gas, steam, and liquids, performs well on dirty or wet gas, and is highly accurate even in difficult installations. If you're measuring natural gas, steam, compressed air, or produced fluids in oil and gas, V-cone technology is worth a serious look. For larger line sizes, think irrigation, water distribution, raw water intake, or municipal flow measurement, propeller meters are a proven, cost-effective solution. A propeller meter uses a rotating element driven by the flowing fluid. The rotation speed correlates to flow velocity and ultimately flow rate. These meters are mechanical, durable, and easy to maintain in the field. They're not the right choice for slurries or highly viscous fluids, but for clean water applications in larger pipe sizes, they remain a workhorse technology.
Magnetic flow meters, magmeters, work on Faraday's law of electromagnetic induction. As a conductive fluid moves through a magnetic field, it generates a voltage proportional to its velocity. Critical requirement: the fluid must be electrically conductive. That means mag meters are excellent for water, wastewater, acids, caustics, slurries, and most aqueous solutions, but they won't work on hydrocarbons, gases, or non-conductive fluids. The big advantage of a mag meter is that there are no moving parts and nothing obstructing the flow path. That means low maintenance and excellent performance on fluids that carry solids or particles. Mag meters are the standard choice in water and wastewater treatment, chemical processing, food and beverage, and pharmaceutical applications.
When you need to measure gas flow, and you need a direct mass flow reading without pressure and temperature compensation, thermal mass flow meters are often the right answer. Thermal meters measure the heat absorbed by the flowing gas. The more gas is flowing, the more heat is carried away from the sensor. That heat transfer rate directly corresponds to mass flow. This technology excels at measuring compressed air, natural gas, nitrogen, biogas from digesters and landfills, flare gas, and specialty gases in industrial processes. Thermomass flow meters are also well suited for low flow rates and small line sizes, where other technologies struggle to perform accurately. Here's a technology that solves a very specific and very common problem. You need flow measurement on an existing line, but you cannot shut the process down to install a meter. Clamp-on ultrasonic flow meters mount entirely on the outside of the pipe. There's no pipe cutting, no hot tapping, no process interruption. You clamp the transducers on, configure the meter for your pipe and fluid, and you're measuring. This makes clamp-on ultrasonic ideal for retrofits, temporary measurement, verification of existing meters, and applications where process continuity is critical. It works well on clean liquids in a range of pipe sizes, and it's especially popular in water and wastewater, chemical processing, and HVAC applications. Let's pull this together into a simple decision framework. Start with your fluid. If it's a liquid and it's conductive, water, acids, caustics, slurries, a magnetic flow meter is usually your first option to evaluate. If it's a liquid but non-conductive, hydrocarbons, oils, or if the line cannot be taken out of service, clamp-on ultrasonic becomes the lead candidate. For large line sizes with clean water, a propeller meter deserves a look for its simplicity and cost-effectiveness. If you're measuring gas and you need direct mass flow, biogas, compressed air, natural gas, thermal mass flow is the right starting point. If straight pipe run is a constraint regardless of fluid, V-cone differential pressure technology is built for exactly that situation. Of course, real applications are rarely this clean. A difficult fluid, a challenging installation, or specific accuracy requirements can shift you from one technology to another quickly. That's where a technical conversation with someone who knows the full range of options makes a difference. A few additional factors that experienced engineers always consider before finalizing a flow meter selection: process temperature and pressure. Every technology has operating limits. Make sure your selection is rated for your worst-case process conditions, not just your normal operating point. Materials of construction. The wetted materials, the parts of the meter in contact with your fluid, must be compatible with your process fluid. Stainless steel is not universal. Some fluids require Hastelloy, PVDF, PTFE lined, or other specialty materials. Turndown ratio. This is the ratio of maximum to minimum measurable flow. If your flow rate varies significantly, say a pump that runs at 10% capacity during startup and 100% during full production, you need a meter with adequate turndown to handle that range accurately. Output requirements. Does your DCS or PLC need a 4 to 20 milliamp signal, a pulse output, HART, Modbus, or something else? Confirm compatibility before you specify. Approvals and certifications. If the area is classified Division 1, Division 2, Zone 1, or Zone 2, your meter needs to carry the right EX certifications for that classification. Flow meter selection isn't something you have to figure out alone. At George Grant Company, we represent industry-leading flow measurement technologies including McCrometer V-cone and Propeller meters, Azbil magnetic flow and vortex meters, Eldridge thermal mass flow meters, and Micronics clamp-on ultrasonic meters. We work with process engineers and I&C teams across the Southeast to match the right technology to the right application, every time. If you have a flow measurement challenge you'd like to talk through, reach out to us directly. We're here to help. And if this video was useful, subscribe to the George Grant Company channel. We'll be covering more engineered solutions, application guides, and technical topics built specifically for the industrial professionals who need them most. Thanks for watching.